Lesson: Exploring statistical techniques and forecasting methods. Predictive analytics has become an indispensable aspect of modern supply chain management, providing invaluable insights for decision-making and strategic planning. At the heart of predictive analytics are statistical techniques and forecasting methods that enable businesses to anticipate future trends and demands, thus optimizing operations and enhancing competitiveness. This lesson will delve into these techniques and methods, offering practical tools, frameworks, and real-world applications to equip professionals as certified AI-driven supply chain analysts. Statistical techniques form the bedrock of predictive analytics, offering a systematic approach to data analysis and interpretation. Regression analysis, a fundamental statistical technique, is pivotal in understanding relationships between variables. By applying regression models, professionals can predict future outcomes based on historical data. For instance, a supply chain analyst could use linear regression to forecast future sales based on past sales figures and market conditions. This method is particularly effective when the relationship between the independent and dependent variables is linear. Time series analysis is another crucial statistical technique, especially relevant for supply chain forecasting. It involves analyzing data points collected or recorded at specific time intervals to identify trends, seasonal patterns, and cyclic behaviors. Tools such as ARIMA models are extensively used in time series analysis. ARIMA models are capable of handling various types of data patterns, making them versatile for different forecasting needs. For example, a retail company might use ARIMA models to predict inventory levels, thereby reducing costs associated with overstocking or stockouts. Complementing statistical techniques, machine learning algorithms have gained prominence in predictive analytics, particularly due to their ability to handle large datasets and capture complex patterns. Decision trees, random forests, and support vector machines are some of the popular machine learning methods employed in forecasting. These methods can automatically detect patterns and relationships in data that might be missed by traditional statistical techniques. In supply chain management, machine learning can enhance demand forecasting accuracy by incorporating a wide array of variables, including economic indicators, weather patterns, and consumer behavior data. Moving beyond statistical techniques, forecasting methods are essential tools in predictive analytics, enabling organizations to make informed decisions based on projected future conditions. Quantitative forecasting methods, which rely on numerical data, include techniques like exponential smoothing and causal models. Exponential smoothing is particularly effective for short-term forecasts, as it applies decreasing weights to past observations, thus emphasizing more recent data. This method can be advantageous for inventory management, where timely and accurate forecasts are critical for maintaining optimal stock levels. Causal models, on the other hand, explore cause and effect relationships between variables. These models are instrumental in scenarios where external factors significantly influence demand. For instance, a causal model might be used to forecast the impact of a marketing campaign on product sales, providing a clearer understanding of how different variables interact and affect outcomes. By integrating causal models into their forecasting toolkit, supply chain analysts can develop more robust strategies that account for external influences. Qualitative forecasting methods, while less precise than their quantitative counterparts, offer valuable insights in situations where numerical data is scarce or ambiguous. Techniques such as the Delphi method and scenario analysis rely on expert judgment and consensus to generate forecasts. The Delphi method, for example, involves a structured communication process among a panel of experts to predict future events. This method can be particularly useful in supply chain strategy development, where expert insights are needed to navigate uncertain markets and emerging trends. In practice, the integration of statistical techniques and forecasting methods can significantly enhance supply chain efficiency. Consider the case of a global manufacturing company that implemented a predictive analytics framework to optimize its supply chain operations. By leveraging regression analysis and time series forecasting, the company was able to accurately predict demand fluctuations and adjust its production schedules accordingly. This resulted in a 15% reduction in inventory costs and a 10% increase in order fulfillment rates, demonstrating the tangible benefits of predictive analytics in supply chain management. To effectively implement these techniques and methods, professionals must be equipped with practical tools and frameworks. Software platforms like R, Python, and SAS offer comprehensive analytics capabilities, enabling users to perform complex statistical analyses and build sophisticated forecasting models. These tools provide a wide range of libraries and packages that facilitate data manipulation, visualization, and modeling, making them essential resources for supply chain analysts. In addition to software tools, adopting a structured framework for predictive analytics can enhance the effectiveness and efficiency of forecasting efforts. One such framework is the CRISP-DM model, which provides a systematic approach to data mining and analytics projects. The CRISP-DM model comprises 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. By following this framework, supply chain analysts can ensure a comprehensive and methodical approach to predictive analytics, leading to more accurate and actionable insights. As the role of predictive analytics continues to evolve within supply chain management, professionals must remain abreast of emerging trends and technologies. The integration of artificial intelligence and machine learning into predictive analytics is revolutionizing the field, offering unprecedented levels of accuracy and efficiency. AI-driven analytics platforms can process vast amounts of data in real time, providing dynamic forecasts that adapt to changing conditions. This capability is particularly valuable in supply chain management, where timely and accurate information is critical for decision-making. In conclusion, the exploration of statistical techniques and forecasting methods is essential for professionals aiming to excel as certified AI-driven supply chain analysts. By mastering these tools and frameworks, supply chain analysts can transform data into actionable insights, driving efficiency and competitiveness. The integration of traditional statistical techniques with advanced machine learning algorithms and AI technologies offers a comprehensive approach to predictive analytics, empowering professionals to navigate the complexities of modern supply chains effectively. Through practical applications and real-world examples, this lesson has provided a detailed understanding of how these techniques and methods can be leveraged to address real-world challenges and enhance proficiency in predictive analytics.